Okay, geometry students, today we are going to talk about outcomes and probabilities. The definitions of outcome is the possible results of an event or an experiment happening. A sample space is the set of all possible outcomes. For example, the sample space of rolling a six-sided number cube is 1, 2, 3, 4, 5, or 6. Probability is the likelihood that an event will occur, and it can be written as a fraction, a decimal, or a percent. And it is symbolized by P of A equals whatever the probability is. So let's talk about some probability of these events happening. So what is the probability of rolling a 2 on a six-sided number cube? So the probability of rolling a 2 on that six-sided number cube is 1, because there's only one 2 on there, out of 6. Or we can say it is a 16.7% probability. Number 2, what is the probability of rolling an even number on the six-sided number cube? There are 3 out of 6 numbers on that cube that are even, which reduces to 1 over 2. Or we can say it's 50%. What is the probability of flipping a fair coin and landing on heads? So the probability of getting heads when you're flipping a coin, that's a 1 out of 2 chances, or again, 50%. Number 4, what is the probability of green marble from a bag containing 3 red marbles, 4 green marbles, and 5 blue marbles? So that gives us a total of 12 marbles. So the probability of getting a green marble is going to be 4 out of 12, which we can reduce to 1 out of 3, or we can say it is a 33.3% chance of happening. All right, Lila is spinning a spinner with sections numbered 1 to 8 and recording the results. Event A is spinning an odd number. So event A, we have the odd numbers of 1, 3, 5, 7, and 9. Those are my odd numbers. Event B is spinning a number greater than 2. So my B events are going to be 3, 4, 5, 6, 7, or an 8. Okay, so when we take a look at this, we have a total of 8 possibilities. Okay, so we have for odd numbers, we have 1, 3, 5, 7, and 9. But for our probability of rolling a number that is greater than 2, we have to include in the odd numbers 3, 5, and 7. So only one of those is going to go in just the odd side of our Venn diagram. 3 out of those 8 are going to end up in the middle because we share those 3 with the event, or the possibility of rolling greater than a 2. And that leaves us with 3 left over for our event possibility of rolling a number greater than 2. So those 3 right there are represented right here. All right, and that leaves us with 1, because if you look at those, that doesn't add up to 8. We have 1 plus 3 plus 3. That gives me 7. And we need to represent that last number, which in this case is 2. And that's going to go on the outside to complete our universal set. So we have, oh, sorry, not 1 out of 2, 1 out of 8 on the outside there. And that represents, of course, the number 2, which is not represented in the odds or the numbers greater than 2. Okay, let's take a look at the next page. A random 2-digit numbers 10 through 99 is drawn. We need to find the probability. Well, first we need to define the sample space. If we are looking at two-digit numbers between 10 and 99, that gives me a sample space of 90 possibilities. So what is the probability that I draw the number 32? That's going to be 1 out of 90, which is a 0.01% chance of happening. I'm sorry, it'd be a 1% chance, not a 0.01. 1% chance. And then this for our probability of 32. Okay, so the probability of our odd numbers, I'll just leave my probability up there. The probability of an odd number, there are 45, so because half of the numbers are going to be odd out of 90, which reduces to 1/2, which is 50%. Okay? And then we have the probability of a multiple of 5. Well, if you count, there are 18 numbers between 10 and 99 that are multiples of 5, so it's 18 out of 90, which reduces to 1/5, which is a 20% probability. Okay, I'd like for you guys to pause your video and answer numbers 4, 5, and 6 in Edpuzzle. But let's talk about the sample space first. We are looking at a letter randomly drawn from the word candlestick. So if we look, there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There are 11 letters in the word candlestick, so our sample space will be 11. You can use that and answer the questions 4, 5, and 6 in Edpuzzle. Okay, let's take a look at number 7. We are looking at 3 coins that are tossed. Find the probability that 2 land on heads. Our sample space is 8. The probability that 2 will land on heads is going to be 3 out of those 8 coins, 3 sides of the coin, and that's going to be 0.38, or we can call that 38%. Okay, I want you to do number 8 on your own and come back and check your answer and see if you got it correct. Okay, check your answer. And let's move on. Let's take a look at number 9. What is the probability of drawing a 9 or a diamond from a standard deck of cards? Well, our sample space for a standard deck of cards is going to be 52, because there are 52 cards in a deck. 13 of those are going to be diamonds, and then there's going to be 3 9s left over. So that gives us a total of 16 out of that 52, which will reduce to 4/13, which is a 31% probability or 31% chance of happening. Number 10, we have a credit cards that they place a 3-digit security code on the back of their cards. What is the probability that that code starts with the number 7? Okay, we have a 10 as our sample space because our digits could be 0, 1, 2, 3, 4, 5, 6, 7, or 10 possible digits. 7 is only one of those possible digits, so we are going to do 1 out of 10, which is a 0.1, or we can say a 1% chance. Number 11, 2 dice are rolled. What is the probability of not getting doubles? Not getting doubles. So my sample space here is going to be 36. Okay, we have 6 sets of doubles, and that's going to be 30 out of 36, which can be reduced to 5/6, which is going to be 83, or an 83% chance. Okay, I want you guys to try number 12. Pause your video and come back and check your answer. Check your answer for number 12. Sample space was 47, and there are 30 songs that are not Katy Perry, so 30 out of 47 which will give us 64%. Okay, let's take a look at the next page. We are talking about tree diagrams. A tree diagram is a way to find the total number of possible outcomes. For example, Miguel is going to select an outfit from 2 different t-shirts, tan and red, and 2 different pairs of shorts, gray and khaki, and 3 pairs of socks, black, navy, and white. I'm going to draw the tree diagram to represent all possible outfits, and then you can pause the video and copy my drawing. Here's my tree diagram for the tan and red t-shirts, and then the gray or khaki shorts, and the 3 pairs of socks, black, navy, and white. Let's use this tree diagram to answer our questions. How many outcomes are there in the sample space? There are 12. We do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12 possible outfits. What is the probability that Miguel will select a tan shirt, gray shorts, and black socks? That is going to be a 1 in 12 probability. What is the probability that Miguel will select an outfit with red shirt and gray shorts? If we look at the red shirt and gray shorts, that gives me 3 possibilities out of 12. We're saying we don't care what color socks he's going to choose, which will reduce to And what is the probability that Miguel will select an outfit with khaki shorts? Khaki shorts, not caring about the t-shirt or the socks, gives us 6 out of 12 possibilities, or 1/2. The fundamental counting principle is another way to find total possible outcomes, especially when there are a large number of them. For example, a deli is doing inventory of their sandwich ingredients. They have 6 different types of bread, 8 types of meat, and 4 types of cheese. The way that the fundamental counting principle works is that we'll take all of those possibilities and we will multiply them together. So we have our 6 types of bread times our 8 types of meat times our 4 types of cheese. And that means that we have 192 when we multiply all those together, possible sandwiches. Okay? Go to the next page. We have some tree diagram practice here. We're going to decide which pizza to order for dinner. Your choices are, for crust, are regular, thin, and deep dish. You want only 1 topping and will choose either pepperoni or sausage. So let's construct a tree diagram to show the possibilities that we have choosing 1 crust and 1 topping. So I'm going to pause the video and put up my drawing, and then I want you to copy it. Okay, we have our regular, our thin, and our deep dish with our 1 toppings, either pepperoni or sausage. So how many possible outcomes are there? We have 1, 2, 3, 4, 5, 6. So we will say there are 6 possible outcomes. I want you to do number 2 in Edpuzzle and see how many outcomes there are for if we decide to add a 3rd topping choice. Okay, this fundamental counting principle, this example, we are at the Outback Steakhouse. You can choose from 5 steaks to cook to your liking and have a choice of 3 different sides shown below. So we have our New York strip, our filet, our ribeye, our porterhouse, our sirloin. We can have them rare, medium, or well done. We can also have mashed potatoes, baked potatoes, or sweet potatoes. So how many different, or how many steak dinners are possible? Well, we have